As we pull data from the internet, there's two standards that we're going to most commonly see. You may see CSV files or text files, some things we've already seen, and you'll definitely see TIFF files, JPEGs, raster file formats. But there's two formats that we need to talk about because they're very commonly used. The XML standard was the standard that was used primarily over the last 20 years, but it's been displaced by JSON, and I think JSON is going to become more of the standard. But XML will still be there. It's not going to go away. So let's talk through XML a little bit. So the XML format itself is fundamentally very simple. You have tags, and typically you'll have a start tag with an end tag and then some comment in between. And the way you can tell it's a tag is because there's a less than symbol and then the tag name. And then the end tag has a less than symbol, a forward slash, and then the tag name. So that's the start of the tag and that's the end of the tag. Now, the greater than is also important because each portion of the tag, like here the start tag, is going to start with a less than, end with a greater than. And then the end part of the tag is going to start with a less than, end with a greater than. Okay? So start tag, end tag. In between, content. And that content can be additional tags. And the tags don't have to have content. They can just start with a less than and then end with a forward slash greater than. You don't see this too much anymore. Much more commonly, you'll almost always see a start tag and an end tag, and if there's no content, this will just be blank. Okay? Now the other component to XML is that you can have attributes within a tag. And so here I've said key value. So you have a key, which is really the name of the parameter, and then the value, which is almost always in quotes, doesn't have to be. If it's a number, doesn't need to have the quotes. Okay, but you can put quotes on it if it's a number, and that's often done. So these are attributes that are associated with the tag. Now note that that's a little different from attributes in GIS, but it's the same idea that we've taken something and added attributes to it. Okay? Now, once you take a look at this and we realize that we can take and put tags inside of tags, we can suddenly do very complex information in a very simple document format. And XML stands for Extensible Markup Language. That's the XML. Okay? It's the underlying standard. One of the languages that is used, that uses XML as its base is HTML, or the language that all web pages are written in. And if you go to any web page and you say View Source, you'll start to see, oh, here's the start tag for the HTML. Down at the bottom of the page, there's the end tag for the HTML. There's the start for the body, which is the content that you see. And down at the bottom, there's an end body. Now, there's a lot of other information in between here. Here's some metadata. Okay. Here's a title, start tag, end tag. You may notice the metadata kind of violates the standard. It doesn't have an end tag. Some tags don't have to have that. Almost all do. And this is the header with the head tag, start head tag, end tag, and head tag. And then there's lots of other information. And you can see that it's hierarchically organized. In other words, you can have tags inside of tags, and you can do that as much as you want. And that's how the structure of all web pages is created. So like here's a bunch of unordered lists, and this is used for the footer down at the bottom of the page, down here. All right, so tags inside of tags inside of tags. And here's an example. This is an XML metadata file, a section of it from Esri. So you've got start metadata, end metadata, start the Esri portion of the metadata. Here's the create date, create time, ArcGIS format, some other stuff. Some of it you'll look at and not know what it is, and that is just fine. And here's a smaller example of HTML. And then there's Keyhole Markup Language, or KML, which is a text-based language. And it's one that has coordinates in it, that we can get into, because once we understand the structure of this, we can then parse it so that we can pull out geospatial information like this, and that's what we're going to do. KML is heavily used with GIS data. I see it all the time, and I regularly have to use Python to go in and pull out geospatial data from it. It's a little bit different language, so sometimes if you try and bring keyhole or KML files into ARC or another GIS package, it won't get you everything you need, because KML can be very complicated, much more complicated data than a shapefile. So sometimes we have to go into it with Python to get what we need. This is where I'll mention W3 Schools. It's a great place for learning HTML, JavaScript, JSON, other formats that are used on the web. That's where the W3 comes from, World Wide Web. But actually, it's also got great Python tutorials now in SQL. It's a wonderful free resource, and I really like their tutorials. I use them personally to use new things, learn new things on a regular basis. Okay, so to get this good information out, we've got to be able to go in and go into these big blocks of text and find what we're looking for. Okay, now to do that, there's a function called find, and there's actually a number of different ones, but we're going to use find. Okay, and once we have some text, like up here I've got some text that's got latitude in it. Okay, start tag, end tag. Well, what I can do is I can use find to find the start of the latitude tag. Okay, so the latitude start tag. Start index will come back with an index, but it's going to come back to the start of this string. It's not going to come back to the start where that number is. The number is what we want. It's going to come back with a start index that's going to point here. Okay, so the problem is to move from here to here, we need to find the length of our start tag, which we know what it is because we programmed this. There's our length, and then we add that to the start index to go from here to here, and now we've got the location of where our number is in our file. Then we can find the location of the end tag. There's the end tag or the end index. And now text is a string, and we can subset our string using this approach where we do bracket and then the start of the text we want and the end of the text we want, really the character after the end. Okay, and then we do that between on either side of a colon, inside of brackets. Okay, and we're really saying here that we want to go into the text and we want to pull out of the text everything from start index up to, but not including end index, or I should say start index plus length. Okay, and that will give us this text. Then we can take that text, we convert it into a floating point number, do that for latitude and longitude. All of a sudden we've got a geospatial coordinate. Okay, that's basically how we'll do it. I also left this little note in here because every once in a while we have to go into DMS coordinates. They're a little strange, especially because the degree symbol is this /xb0. That's in hexadecimal. Okay, so this will just show you how to do that, and we can use the same structures we're doing up here to break these up, but don't worry about it unless you're having to break up these DMS coordinates. Okay. Oh, and then I should mention, on a regular basis when we pull these out, there'll be spaces on either side, and you can get rid of those spaces by using strip. So just take your text and do text.strip and set your variable equal to that, and that'll remove any white space on either side of the string. Okay, so let's get into parsing XML. So first, I'm going to show you how to parse XML without a parser, which may sound a little bit funny, but this is what we do because it's pretty easy to parse it. And I'm going to take this code and paste it into a Python script. Now we have a block of text like this. I can put this into a variable by doing that. The triple quotes, triple double quotes, will take everything that is in here between the triple double quotes and make it a string. So it's just a handy way to do strings if they hit multiple lines on a file. All right, then I can go ahead and create my code to look for my keys. Okay, I call these keys just terminology to say what's the text that we're looking for that is our search key. Okay, so I've set those up knowing, I want to go find this. So there's my start key and my end key. In fact, that'd be better variable names. All right, let's go and run this, see if it works. I've got the length of my end key, sorry, length of my start key. So now I can go and find it. And that did not work because I called my variable some XML instead of test. So let's just change that. As you can see, I get errors all the time. Okay, there's our start index, which is 192. And now we can go ahead and find the end. But notice I'm also putting in here start index plus length of key. In other words, when I go to look for this end key, I don't want to start back up here at the top. Okay, I can start right after the end of our start key and start looking for our end key. And there's more on why we will do that in a minute. Okay, now I've got my end index. So there's my start index, my end index. Okay, and now I can go ahead and go start index plus length of key, colon end index. And now I've got, oops, maybe we should print this. My coordinate. Okay. Now notice that also this doesn't break out latitude and longitude like some of the formats do, so I would need to go ahead and use split to break that up based on the comma, and then pull out the longitude and the latitude. Okay, so now we need to be able to parse large files that have XML in them. And here's a little sample of a KML file. And I brought that into Python, and I've wrapped it in triple double quotes. Triple double quotes is a way to be able to have strings in Python that have new line characters in them. So notice I don't have to do anything for this string. I can just dump it all in between these triple quotes and set a variable equal to it. And now I've got a variable with a string in it, and that string can be long and complicated and all works well. Okay, so the way we go about doing this is we set up this little piece of code, and what we want to do is we want to go in and find our coordinates. Right now, when you go in and parse a file, you'll be looking for the spatial data like we have it here, bracketed by a start tag and an end tag, which is really common. Sometimes each latitude and longitude is broken out separately. That's pretty common. You may also look for things like other information like the name or an address, descriptive information about a feature. All kinds of information can be in these files. You can use the same approach to pull all of that out. And what I've done is I've set up a start and an end key here. So the start tag being the first key, and then the end tag being the end key. I find the length of the first key. Okay, and then I use find to find out where the start key is in my file, or really the first start key is. So that's at character position 192. Okay, and then I'm going to find my end key, but I'm not going to start at the start of the file. I'm going to start at start index plus length of key. In other words, we found this character. I want to go all the way over to this character before I go looking for the end tag. Okay, now that's more important later on when we're doing multiple entries in a file. We're looking for multiple entries, okay? But I'm going to go ahead and do that. And now you can see I've got an end index and a start index. And now I can go ahead and say start index plus length of key. Use that to then pull data out of our string up to but not including the end index, okay? So we're going into our string with brackets. That's how we pull data out of a string, using this for the start and this for the character after the end of our string. Okay, it's a little bit different in how it works. If we step, we'll see we've got our coordinate pulled out. Now, notice that's still a string, and it's got our longitude and latitude, but we know how to use split to break that up. You can pull out the longitude, convert it to a floating point number, convert out the latitude, do the same thing. Now we've got our lat long. Now what we need to do is be able to repeat that and do that over and over again in a file. Okay? So typically the way that would appear in KML, and this happens in pretty much all languages, is you'll have some start end tag that includes a block of text for each feature in the file, and those will just be repeated over and over again. Okay, so the problem is we need to go from this one, pull the information out we need there, then go to the next one, pull the information we need out there, go to the next one, and then you'll probably write these out to another file format like a CSV. Okay, I'm going to go to the website and I'm going to pull in some information. Don't need that anymore. Okay, very similar to what we did before. We're going to have our start and end key, but I'm also going to have the length of each of these keys. And then I'm going to go into a loop. And I'm going to say while start index is not equal to -1, go ahead and find things. And I'm going to just loop through this so you can see how it works. And so we look for start index. Sorry, we're going to loop while start index is not equal to -1. Okay, well, it's 0 now, so that's going to work. Start index came back from our find as 194. Okay, so we found a instance of our start key at character position 194. Great. The reason this -1 is here, and the reason we need to have an if statement here to see if start index is -1, is that when we hit the last start index, notice that we're not starting at 0 all the time. The next time we loop through, we're going to start at 194, looking for the next occurrence, or after 194, looking for the next occurrence. So we're going to go from here to here to here through our file. When we go past here and we look for our start tag, we're not going to find it. And what find will do is then return a -1. So when find returns a -1 for start index, we won't go into here, and our loop will terminate. Okay? But right now, we're good to go. We've got a start index that's not -1. We can now do our find as we did before for our end tag, 216 to 194. We go ahead and add the length of our start key, pull out our coordinate. There's our coordinate. Now, we could set start index equal to the end index, but just to make sure, let's set it equal to our end index plus our length of our end key. In other words, we are right here right now. Let's move our start index from here all the way over to here so that we skip all of this content just in case, just to be sure. Okay, and then we'll start looking for our next entry. We find our next entry. There it is. Happens to be the same because I just copy and pasted code for this example. But normally they'll change. Okay, now when we go to do start index this time, we're at 576, which is actually right here. Okay, no more coordinates. So we execute the find. It's going to come back with a -1. Means we're done. If statement doesn't execute. We're done with our loop, and we're finished, which is what we want because we don't want to sit there and loop forever. All right. Now, the next step, of course, is not just to print the coordinate, but to go ahead and probably up here, open a file to write the data out. Then we get our coordinate, probably break it up into latitude and longitude, write that out to a file right in here. And then at the end of our script, go ahead and close our file. And we've got a script that will parse through any XML format, pulling out geographic data and writing it to a file, probably a CSV. Now, you can also, of course, as I said earlier, use that to pull out other information like this descriptive information, names, measurements, whatever. And you can use this to convert just about any text format for geospatial data into any other format. Now, I do need to mention that there is a XML parser. Okay, there's actually a number of them. Here's one, xml.parsers.xbat. And this is the code to go ahead and use the XML parser. In other words, this is a library that is supposed to help you read XML code. I have taught this in the past to students, and they all agree that this is actually easier than using the XML parser library. So that may not be the case in the future. XML is challenging to parse, and there's a trend towards having converters that will convert XML to JSON, which we'll talk about in a little bit. That may be how we eventually get easier to use parsers. But in the meantime, it's a challenging language to parse, so usually I do it by hand. I don't use a library because it's actually more challenging to do the library than it is to just write what ends up being some fairly simple code to cruise through the file and find what I need. Okay, there may be instances though when you want to use one of these parsers, and there's some information here, and just note that there are different ones. You may want to try some different ones and even keep an eye out for one in the future that will do a better job. Have fun.